Hi everyone, I'm Tom Kralidis, and today I'll be talking about implementing OGC APIs using Elasticsearch and Pi Geoapi. Today I'll give you an overview on some of the OGC API efforts, as well as a 30,000-foot view into the Pi Geoapi project. I'll also talk about how we integrated Elasticsearch into a Pi Geoapi dedicated backend. And finally, I'll also give an example of how we're using this integration in production. Overview on OGC. So the Open Geospatial Consortium has been around since 1994. It's an international standards development organization for making standards around formats and interfaces and APIs and web services and so on. Some of you may be aware of something called Web Map Service or the WMS specification. That is a map API that's been around since 1999 and still in use today by a number of organizations. Around 2016 or 2017, the OGC decided to uh, look at all the different web service standards that are in the consortium and do a clean break and come up with the OGC API effort. So the OGC API effort again is a clean break from the first generation OGC web services, which were focused on things like service-oriented architecture or XML over RPC. This generation of OGC API standards are more focused on being developer friendly and using RESTful patterns and approaches, as well as modern technologies such as JSON, OpenAPI, Swagger, and so on. So it's a very lightweight approach to doing APIs, which is in concert with what's going on out there today. So there you can see an example at the bottom of the slide of how our first generation our first generation web services worked, and there you can see how they work in the current OGC API framework. The OGC APIs are a modular specification approach. So they're designed as building blocks. So you can use parts of one API and combine them with other parts of an API, which really speaks to reusability and not repeating ourselves throughout the API activities at OGC. Here's an overview of the current OGC API standards. The ones with the green outline are already publicly adopted standards. As you can see, we have a number of standards that deal with maps or vector data, points, lines, or polygons, satellite or raster data or imagery, tiles, routing, and other kinds of metadata, other kinds of standards with regards to different workflows. Having said that, how does PyGeoAPI fit in? PyGeoAPI is a Python server implementation of the OGC API standards. It was started in 2018, and it's a community project within the open source geospatial foundation. Overview on the project: it's a geospatial data API framework, so it's written in Python, and it actually has a Python API. You can use the framework without having to have a web front end. I should also mention that it is an OGC reference implementation around a number of the OGC API standards, and there's a large international team of contributors who are contributing different pieces to the project. So that's always encouraging and appreciated. Here's how PyGeoAPI looks from an architecture perspective. So I mentioned the Python API as at its core, which we see in the middle of our diagram here. We have a web layer on top, which basically allows you to put any Python web framework on top, such as Flask or Django or Starlet, if you're into async for that matter. Everything is driven by a YAML configuration, and at the bottom of it is basically all of our data adapters, or what we call data provider plugins. So our data provider plugins allow you to connect your data into the PyGeoAPI core framework, which allows PyGeoAPI to serve it accordingly through the OGC API specifications. So all of our data providers are some of the examples of data providers are Elasticsearch, which I'm going to talk about soon, CSV or raster imagery data, and or data on a file system, and so on. So we have a number of different data providers that help provide get users up to speed with connecting their data into PyGeoAPI quite seamlessly. How did we actually integrate Elasticsearch into PyGeoAPI. So Elasticsearch is one of our core provider plugins. As you can see here, it's the most it has the most widely implemented support. So it supports spatial subsetting, it supports temporal subsetting, it does sorting, property filters, and displays and other aggregations. So it's probably the most mature plugin at this point in PyGeoAPI, and it does get a lot of use throughout a lot of organizations across the world who have elastic geospatial backends. Here's a screenshot from our documentation, and this is really how easy it is to connect your Elasticsearch backend into PyGeoAPI. You basically specify your Elasticsearch instance and the index and a field for identifiers. And if you have temporal capabilities in your Elasticsearch index, then you can specify them there, and that is it. So once you update the configuration with your binding information, as we see here, your Elasticsearch geospatial index is automatically published to PyGeoAPI, supporting all of the OGC API standards. We also support an OGC standard called Common Query Language in our Elasticsearch backend, and that allows for very fine-grained comparison filters and Boolean and logical filters. So basically, this is more aligned with the Elasticsearch DSL, if you will. So, but CQL being an OGC standard or draft standard allows for a different JSON syntax to be expressed through the standard. So basically, what we do here is translate the OGC CQL into the Elasticsearch DSL to do the equivalent queries underneath. In production, there's a number of organizations using PyGeoAPI across the world for their various requirements. Here in Canada at the MSC, we use PyGeoAPI to serve a number of Elasticsearch-based geospatial indexes through our MSC Geomet API platform. It's a 24/7 mission-critical platform, which provides weather, climate, water data both in real time and archive data, and a lot of the data that we serve is made available through Elasticsearch. Here's an example of one of them, our climate station. So here you can see we have an Elasticsearch backend, which is providing a very simple HTML output, as well as we support JSON and JSON link data. The JSON is actually GeoJSON, which is also an international specification, which Elasticsearch plays very well with, and is one of the cornerstones of many of the OGC API standards. That's my talk for today. I thank you for attending and listening to my talk. There's some links on the project itself, so hopefully we'll see you somewhere in the PyGeoAPI community. Thank you very much for your time.